Good morning, everybody. So today we're going to look at chemical changes versus physical changes. So far, until yesterday with a couple of videos, we've focused on the physical, and we can see those with observations. So you're talking about your senses as far as, what it looks like, what it smells like. Even our states of matter are physical because you're talking about still staying the same thing, just changing the motion of the molecules within that. So when you think about the dry ice, for instance, all right, the dry ice starts as carbon dioxide, all right, and that sublimation is the carbon dioxide coming off of the dry ice. So it's carbon dioxide to begin with, it's carbon dioxide to end with, kind of thing. When you're talking about chemical, all right, chemical properties, chemical changes, you're changing from one thing to another. Now, we need to be aware of conservation of matter in this case because you can't just create something. So when you go back to, medieval times or whatever, when you're talking about the alchemists, they were trying to create gold, but they didn't have gold to start with. So that's why they were always unsuccessful. You can't just create it. It has to be combined or bonded with something else. So for instance, with water, we know water is H2O. All right, I can chemically change that and separate out the hydrogen and the oxygen. So I can get hydrogen and oxygen from water because it has hydrogen and oxygen in it. I just can't create, I couldn't create gold from water because there's no gold in that chemical formula of the molecule of water. All right, and so with chemical properties, we're looking at that reactiveness. Can it, combine with other things? And if it does, how do we know when it does or when it separates from being combined with something else? So that's what we look at with chemical changes. And so you're talking about burning something, digesting something, fermenting something, just plain reacting with something. So, the whole, when you think about our exploration of the moon or our plans to go to the moon, the whole reason we're planning to go to the moon is because we want, one, less gravity so we can get to Mars, all right? And two, because we've found water on the moon, we know we can take that water and separate it so that we can have hydrogen and oxygen, which are our rocket fuels. So we can take and go from the Earth to the moon and set up our station on the moon, all right, which is planned in 2024, coming up pretty quickly here. All right, that's the Artemis mission. And then we can refuel on the moon by taking the water that we found on the South Pole in those deep craters where there's no sunlight because they're always in shadow. We found ice down there, and we can take that water and we can chemically separate it and have hydrogen and oxygen. And hydrogen right now is our main rocket fuel. We in the Apollo missions, we wanted it to be oxygen, but it was just too explosive when we were going to blow up on the launch pad. So we had to use hydrogen. All right, from the moon, we can use both hydrogen and oxygen. And 2030 is the goal then to take and go from the moon to Mars. And we have that refueling station on the moon because chemically, all right, hydrogen is explosive, oxygen is explosive, so we can use that as a rocket fuel. All right, so that's just kind of the background about chemical reactions and chemical properties. And then the next video is going to show you what we did in the lab.